So this is kind of an interesting problem. It says that a person is riding a Ferris wheel and is strapped in with a seatbelt, or into the seat with a seatbelt. The wheel is spun so that the centripetal acceleration is a value of g. So I know that my centripetal acceleration has a value of g. Select the correct combination of forces, knowing that we have gravity, the seatbelt, and the seat. So if I draw a picture for this, I have my little person sitting down, and they are sitting on a nice little seat. And they are strapped in with a seatbelt. So there's a seatbelt force pointing down. Seatbelt force, we're going to label that F sub B. We know that there's a weight force of mg pointing down, and we know that there is a possible force due to the seat. The seatbelt and the force of the seat, I would consider those to be normal forces. The seatbelt is pushing down on the person because the person is below the belt, and the seat is pushing up with a normal force on the person as they sit on the seat. So if I were to look at positive y in the downward direction, I'm going to label all my forces. I'm going to get my weight force plus my belt force minus my seat force has to be equal to my mass times my acceleration. Well, I know that my acceleration has a very specific form. I already have this value of mg. So I have mg plus fb minus ff is equal to mg. Well, that's interesting because I can see that I have mg here and mg there. So as looks like my entire centripetal acceleration is provided only by my weight force, which really reduces down to that the seat force and the belt force have to be equal to each other, but in opposite directions. So if I look through this, I know that I have a weight force. So I can eliminate out answer A and answer C because they both have zero weight forces. I know that's not correct. The other time that I need is I need to have the weight or the seatbelt force and the seat force to be equal in magnitude. Well, if I look at E, I have 0 and mg. They're not the same. D has mg and 0. That's not the same. The only one that works is when you get mg for the weight force and 0 for the belt and the seat. This just means that the person had a loose seat or a loose belt on their seat, and when they got to the very top of their circle, they were no longer touching the seat because it had 0 force, and they were no longer touching the belt. The belt wasn't pulling them down. So it's really kind of a special case where they're at the very top and they're spinning at exactly the right speed that gravity is causing them to do this little loop. So they're actually in a state of, at that point, weightlessness, or not weightlessness, free fall is a better way to describe it. They feel like they're floating, but they're actually falling towards the earth at in the exact right circular path that they need at the very, very, very top.